Lesson 4 specifically focuses in on derivatives of inverse functions. So it gives us a specific rule of how we find the derivative of f inverse. Okay. With this in mind, notice it says recall from previous courses that y equals f of x. If it's a one-to-one function, it will pass the horizontal line test and will therefore have a unique inverse function. We write that as that f inverse x. We often say the inverse function will undo the original function. That's the whole idea between a function and its inverse, is that they undo each other. Kind of like inverse operations, multiplication, division, undo each other. This can be seen in the test to prove two functions are inverses of each other, since the composition of the two functions produces the identity function. So we did talk about this back in algebra and pre-calc, I believe. And that is the idea that f composed with f inverse of x and f inverse composed with f of x will equal x. Okay, so one of the things we just did in pre-calc not too long ago is our f and g inverse functions show that they are. If f and g are inverse functions, then f of g of x, so fog equals x, and g of f of x, goff equals x. Okay? So that inverse function test still applies. Now, definition of an inverse. A function g is the inverse function of the function f if f of g equals x for each x in the domain of g, and g of f of x equals x for each x in the domain of f. The function g of x is denoted by f inverse of x. Very much what I just said in that together they have to equal x. The inverse, more than anything, so we don't have to deal with that f and f inverse together, is often used as g. Okay? And then this goes back really to algebra for this one. If the graph of A, can't read, the graph of f contains the point A comma B, then the inverse graph contains the point BA, B comma A. And that's what we did back in algebra 2. You probably did it back in algebra 1. Find an inverse, you take the x and the y and you switch them, right? Okay, so some basic details about inverse functions. Now, this is kind of our intro business here. They give us a table with f of x, and g of x. It asks us to use the reflective property of inverse functions and the function values for f and g in the table at right to complete the table of values for the respective inverses, f inverse and g inverse. Then use to answer each of the questions below. So they want us to fill out this table of values for f inverse of x. Okay. So f inverse of x is going to be based on the values of f of x, yes? How do you find the values for an inverse? You take the original function values and switch them, yes? So if we are trying to find inverse, we have to take our x and our f of x. So this would originally be x and y. In f inverse, they're going to flip-flop. So this point that is x is 3, 2 is f of x. When we flip that for the inverse, becomes 2, 3. Okay? The point on the f that is 1 comma negative 1 on the inverse becomes negative 1 comma 1. Am I making sense? The point negative 1, 4 becomes 4, negative 1. Okay, so just know if they give you f values, x and f of x, they switch, become x and f inverse. Can the same be done for b? Most certainly. This time, though, it's using the x and the g of x values, of course. So 3, negative 1 becomes negative 1, 3. 1, 0 becomes 0, 1. Negative 1, 3 becomes 3, negative 1. Okay. We have that chart filled in. Now let's do some compositions. F of G inverse of 0. You guys know the drill. It makes it real easy since we have our charts filled in. We can use our charts. What is G inverse of 0? 1. And if we didn't have this chart that I just filled in on part B, G inverse of 0 would be going and finding where is G 0, and then where did that come from? 1. And then what is F of 1? -1. That's all that is, just basic practice here. So F inverse of F of -1. What is F of -1? 4. And F inverse, huh? Okay. And F inverse of 4 is the -1. Okay, yeah. And when it says F to the -1 power, I read that as F inverse or G inverse. So this is F inverse of G inverse of -1. What is G inverse of -1? 3. So then what is F inverse of 3? No one's answering. Okay, it's not on the chart.
Custodian Johnson, please come to the high school office. Custodian Johnson.
So in my notes, I have it listed as not defined, or you could say undefined if you want, because we don't have that knowledge. Okay, we don't have that knowledge. They didn't share that knowledge, so we don't know that answer. So it is just not defined on this problem. Okay, and I think really what they're trying to get you to do is they're trying to get you to mess up and say that it's 2, but it's not good. G inverse of F inverse of 4. What is F inverse of 4? And then what's G inverse of -1? Okay. Moving along. Getting easy stuff out of the way, right? Okay. Top of the next page. It mentions a function has an inverse function if and only if it is 1-to-1. Okay. It has an inverse if and only if it's 1-to-1. If F is strictly monotonic on its entire domain, so either strictly increasing or strictly decreasing on its entire domain, then it is 1-to-1 and therefore has an inverse function. Now, they ask us, we're basically going to kind of do a proof here. The relationship between a composition function and its inverse is stated below. So the fact that f of f inverse of x equals x. If you use the chain rule and differentiate both sides, you can find a formula for the derivative of an inverse function. And that's what we're going to do here, is we're going to create our formula. Now, yes, the formula will be shared later, but we're just going to look at, okay, how can you get it if you forget the formula?
So it's like the derivative stuff when we started with originals.
Well, I will say, we get to the formula pretty quickly here, though. That's the good news. We don't spend a bunch of time doing it without the formula. Now, with this in mind, okay, with this in mind, I personally don't want to work, this is essentially a proof, I don't want to work this with an f and an f inverse, and then I'm going to put derivatives on top of it.
It's a proof?
That's essentially what it is. We're creating a formula here. Instead of f inverse, I am going to define g of x to equal f inverse of x. Actually, yeah. And again, this is just so life doesn't get too crazy in this problem. I mean, that's the honest truth here. So with that in mind, I'm going to rewrite this, and we're going to be doing the problem. Instead of f inverse, we're going to be doing f of g of x equals x. And it's just going to be easier to work with. Okay? That's the only reason I'm doing that. Now, we're going to start by taking the derivative. I'm going to write it out just, I'm going to say that, okay, I'm going to say d of x, d over d of x. So that's going to, I'm going to tell myself to take the derivative of f of g of x. And that's going to equal taking the derivative of x. This is me. All I'm doing here is I'm showing that we're going to take the derivative of both sides. We're going to differentiate. That's what that d dx means. Now, on the left, what do you know about the derivative of f of g of x?
F prime g of x times g prime of x.
Derivative of the outside, so f prime of g of x times derivative of the inside, so times derivative of g of x. And then the derivative of x with respect to x is 1.
Because if it wasn't with respect, wouldn't it be like dx over dy?
Something, but we never put dy on the bottom. That just doesn't happen. And keep in mind, think about it this way. If you multiply dx times x, you get dx over dx. So that's going to reduce to be 1. Okay, remember, our job is to find the formula for the derivative of an inverse, which means the derivative of an inverse. What am I trying to find? The derivative of an inverse? Well, that means I'm trying to find the derivative of f inverse. But what did we use for f inverse? G of x. So I'm trying to find g prime. So we're going to solve this equation for g prime. How do I solve for g prime? Divide by that other junk. So g prime of x is equal to 1 over f prime of g of x. Okay? Now, we've solved for the derivative of the inverse. I'm going to go back now and substitute in that g prime of x was what? Or g of x was f inverse of x. So this is f inverse prime. So the derivative of f inverse of x is going to be equal to 1 over f prime of f inverse of x. So all I did there is I took my g's out and put my f inverses back in. And I kind of made it ugly again. But this is the formula we think of. So the derivative of the inverse is equal to 1 over the derivative of f, or f prime of f inverse of x. That's the formula you have to become familiar with, and you have to know how to use. Okay? Are we okay with how I got the formula? Whether we like it or not, are we okay with how I got it? Because I know we're not liking it, but that's not the point. It is. Okay. Let's see if I can keep example 2 straight as I go through it. Example 2. They give me f of x. 4x minus 3. They give me f prime at 2 is equal to 4. And they want me to find f inverse of the derivative of f inverse of 5. Okay? Now, I'm trying to think where I want to start here. Okay, so they give me an f function. They give me an f derivative at 2, which we'll need later. Okay, so first of all, if they're asking me to find, if they're asking me to find f inverse of 5, keep in mind that for an f function, the input is an x value. Output is a y value, correct? Here, this is an f inverse of 5. So f inverse of 5 is really what type of value? That is the input on a inverse. That's going to be a y value. Does that make sense? Normally on a regular function, an input is x, output is y. On the inverse, it's just the opposite. The input is your y, output is your x. So that's the first thing I want to consider here. Okay? Now, with that in mind, the output, why did I do that? Okay, yeah. The output is a y value. What do we also know up over here? F of x equals 4x minus 3, right? This is the original function. F of x is the same as saying y equals. So it's kind of the idea, if this is 5 comma something on the inverse, what is it on the original function? On the original function, it's going to be let me think about it this way. Something comma 5, right? So like right here, for f inverse, it's going to be 5 comma something. Well, then that means over here on f, it's going to be something comma 5. Okay? Sorry, my brain is lapsing a little bit on how I want to teach this. What it can let me do, let's put 5 into my original f equation. It's going to help me find my other variable. Now, where do I put 5 in?
Y.
We put it in for the y. So we're going to say 5 equals 4x minus 3. Do some math, right? For x equals 8, so x equals 2, yes? Okay, so here's what I know right now. On the original function, f of 2, when I put 2 in, I'm going to get 5 out, correct? What else does that tell me? F inverse of 5 is going to equal 2. Now that's a needed value I'm going to need. And that's what I was trying to do my prep work for. I guess maybe I should have shown you why we were going to need that, but I jumped the gun there. Okay, we're going to use that formula we came up with from up above. That formula we came up with from up above, because we're trying to find the derivative of the inverse, was f the derivative of f inverse of x, and it was 1 over f prime of f inverse of x. That's my formula from up above, correct? We're being asked to find what? The derivative of f inverse of 5, yes? So what can I put in for my x's here? Those x's can become 5, because that's what I'm being asked to find. So I'm going to be doing the derivative of f inverse of 5. And according to my formula, that's 1 over f prime of f inverse of 5. All I did was fill 5 into my formula for x there. Okay, keep working this formula. 1 over f prime of, yes, f inverse of 5 is 2, equals 1 over what's f prime of 2?
Yeah.
4, because they provided it. You just have to realize they provided it. I could see the pause. So what did we just find? The derivative of f inverse at 5 is equal to 1/4. Okay?
Can I see the students who will be going to the Indiana State Police field trip tomorrow? Just give you some information before tomorrow. If you can come down to the office before you leave, thank you.
Okay.
Me and Doc are going to be showing names tomorrow too.
Is it just you and Doc left? Oh, because of all the field trips. What field trip are you on tomorrow?
Sportsology.
Okay.
That's what the other 4 names got through.
Okay. I couldn't remember what field trip you were on. This was like, wait, do you need to go down for the state police one? I just know you're on some field trip. That's all I know.
You and Arnold? No, Spencer. Will also be
Yeah, it'll be me and Spencer.
You're
In
gonna
Arnold's class.
knock out a bunch of homework tomorrow.
Okay.
You're gonna have lots of time
Well,
on your
Mr.
hands.
Arnold's going to assign more work tomorrow. And I already know his other.
Okay, well, you'll have lots of time to get his work done tomorrow. Okay. You've kind of seen a process here, okay? This is one, I'll be honest, it kind of sometimes takes me a moment to wrap my brain around. But when you look at the top of the next page, they kind of have some steps mapped out for us, okay?
This looks simple. I feel like they're going to add some sine, cosine, homework. Throw me completely off.
Natural.
Well, there's always a possibility,
Net
but,
log for sure.
okay.
We'll see that.
If f and g are inverse functions, such that f of g of x equals x and g of f of x equals x, where f of a equals b and g of b equals a. So that's just, that's standard inverse information. To find g prime of b, remember g is going to stand for the inverse in this scenario. So to find the derivative of the inverse at b, for point a, b on f of x, first of all, okay, we didn't have to do this on the last one, but find the derivative of f, because you're going to need that at some point, okay? If they would not have given me f prime of 2 is 4, we'd have to find that. But the derivative of f prime of x would be 4. So f prime of 2 would be 4. We could have done that. They just didn't make me do that. So you're going to find that derivative. If you're only given your b value, what you're finding for, then you're going to have to set b equal to that original equation to find a. That's what we did there when we set 5 equal to 4x minus 3. Find f prime of a. Okay, that was the value we were given. You're going to have to find that times. And then step 4 is using the formula. G prime of b equals 1 over f prime of a. Okay, that's a shortcut. We're going to use this formula here is what's going to make more sense. The derivative of the inverse is equal to 1 over f prime of f inverse of x. Okay? Now, something good to notice. Inverse functions have reciprocal slopes at corresponding points. Okay? So, inverse functions, if you have the point 2,3, it becomes a point 3,2. Well, a reciprocal slope, a slope of 3/4 would become 4/3. And that's going to be helpful in our next scenario. That I want to talk about this, but I don't know if we'll get through it.
I said we got 3 minutes according to that clock.
Yeah, my watch now says 3 minutes. I hate to, but I think we'll get interrupted in the middle if I try and go through it right now. So we'll probably talk about it Monday. I will say, this is a formula you need to know eventually, okay? Sooner rather than later, of course, but looking forward to AP, this is something you need to know. I think it was Doug a couple of years ago that, what did he do? He said, because it's, on this side, it's inverse then derivative, right? You've got F inverse and then derivative. So it was ID. I don't remember what he said about it, but then on this side, it's the derivative and then it's the inverse inside. So it was something about ID equals DI. So inverse derivative and then it's derivative inverse on the other side. I can't remember exactly how that was, but it's something along those lines. Okay? So we will work Monday on mastering this formula, or at least getting better.